That would have been unfortunate. And we'll share sound. Great. Well, shall we get started with the folks that are here? We'll start with, we're going to listen, talk about the works you guys submitted. We'll take questions, and then we'll move into continuing with envelopes and synth side, randomness, and sequencing. Cole, you're at the top, so I'm just going to start with you. All right. Let's see if I boot up here if it's going to work.
Oh, did you replace the new speakers?
These are not the new speakers that are supposed to go in here. I just got lazy and put these up for the time being so that we have something that's decent. Sharing sound, stereo, high fidelity, of course. Okay. Does anyone know if there's a way to hide this bar? I don't think there is, but I'll do our best I can. Okay, so Cole is going crazy with some P-bind stuff, and we're going to talk about those later in life. But let's see here. Did we boot? Seems like we did. Zoom audio. We'll see what happens. Cool. So these are your notes then. Great. So what I'd like to see, Cole, this is great. I do want to see you though also working on sketches that are incorporating the stuff we're talking about in class. So it'd be good to have seen some envelope generator or some sort of modulation techniques utilized. But I'm glad to see you digging into the P-bind stuff. And we're definitely a deep dive on this. This is essentially P-binds are what allow us to create kind of traditional style sequenced musical compositions, which can be very strict with the beginning and end, or can be algorithmic in nature. So these are really cool. Thank you, Cole. Wow. Did you send me a note this morning saying, someone sent me a note saying their computer was having a hard time? That wasn't you, was it? Okay. Okay, you want to tell us anything? Great. Beautiful. Lovely. So arm shape. We're creating 4 of these. Interesting. And then are we? I think we're throwing away a couple things here. Oh, so they're getting mixed probably to both sides. Okay, cool. Yeah, way to play and have some fun. Say again? Yeah, that's lovely. Any questions for Maya? Yep. So let's open up here. Good morning. Let's open up. It's fine. Let's open up here. Envelope. We'll make this a little bit bigger so we can see it better. And we'll go to the circle. Come on. Okay, there we go. Here, we'll move this down. And we can search in page for circle. So it creates a new envelope specification with which cycles through its values. For making a given envelope cyclic, you can use the instance method circle. And so circle, unlike others, actually does allow us to create Okay, so the first thing here, the first array is the levels, and the second one is times, and the third is curves. So let's look back at my here. So my essay, we're going to send out a value, and if we hit dot poll on this, excuse me, we're going to hit dot poll right here. We're going to see these values go from 0 to 1. It's going to take 4 seconds to go up to the first one, 3 seconds to go down, and then it's going to pause for a second at 0, which gives us that steady state. So again, notice we're getting this kind of motion. It's going, it's sticking around for a while. And then it just repeats. So it's not dipping to -4, it's dipping to -4.12 e to the -15th. So it's practically 0. It's just that 0 sometimes it's hard to represent in floating point values. And then what Maya's doing here, she's hitting the range button so that it's going based on the ID of this multi-channel value, we're multiplying by 200. And it's so this is the starting point for each one. Each one goes up to 18,800, but they all have different starting points, giving us this nice kind of siren dissonance. We pass these all here, so I'm just curious to hit, see here. I'm curious if we did 2, is that going to change? I actually, see, it's louder, but so if I take this and so now we've got all of them going out of one side. Then if we can, we lose that nice and there's clearly a stereo dissonance going on between the two sides right now, which is nice. Cool, nice job, Mike. Any other questions? Cool. An array is just a collection of some sort of data. Typically, it's an array of numbers. But we could have an array of characters. We could have an array of strings. We could have an array of arrays of arrays of arrays. And then you're going to get angry at me, I know. But an array is just a collection. Yeah, it's an indexed list. Cool. All right. Matthew, homework.
Mine is at the bottom of this all.
Synth 2,
Well, that one, but I did have.
ask your question.
Well, we can play it first. So this is synth 1, but I made a second synth, and I was curious because I wanted to play around with phase shift thing, so I put it just copied the same one and put it at a I for its phase. But I was just curious if what game you used to play for that.
So if we just execute both at once, then it'll play both at once.
Gotcha. Okay.
So does anyone know why? My poor wife just spilled an entire cup of coffee all over the couch. Yeah, so your mole here takes this signal typically would be -1 to 1. If we multiply that by 0.1, we get -0.1 to 0.1. So then when we range it by 10, we're back to 1.
I don't need the mole.
So you're doing a lot of superfluous nonsense, yeah, in which,
So if I wanted to change, so I would change that to.
so if we do this and then exact same thing. So what were you've got, let's see here. So we've got a car wave, 0400, so that's driving frequency. And then oh, so that's the pan position. Yeah, interesting. The effect that's occurring here is actually panning based modulation, which is interesting. So that's what's causing the sidebands to occur. Is the panning effect is moving into the range of human hearing. And what were you trying to do here?
Oh, I was just trying to play around.
I
with
see.
How it sounds like the one at because isn't pi like half the way through the way?
It is.
So I was just curious.
Yeah.
Like,
So if we then did the same thing here, get away with that. How would we affect the volume of these then?
then you can create a synth function afterwards. You can
We could actually just multiply it here by like a
Oh,
-6 dBm. Both of those, same thing. And just to be quicker with it. Creates a cool effect. Thank you for that, Matthew. Yeah. Not by themselves, because we have to have the whole synth. So we could that's just going to throw an error because it doesn't know what we're trying to do with it. So we have to encapsulate this whole synth as a single command. And the other reason for that, there's a couple of reasons for that. One, we haven't gotten to synth depths technically yet, but we're essentially creating a synth signal flow. And when SuperCollider compiles it, it wants to compile that all at once. So here it's saying something like, let's create a sine oscillator. So we've got let's say this is a sine oscillator. And that sine oscillator is driving the frequency of another sine oscillator. And then we have a pan function And we're bringing in another sine oscillator, which is our value. It's at a frequency of 400. And the position is driven by this sine oscillator. And so there's no way to tell it to build this step by step off of real time. It needs to actually look at all of these instructions together and compile them into a single signal flow. Does that kind of make sense? We can create opportunities in here to affect this synth after we've instantiated or built it. But when we're building something signal flowy like this, we have to do it piece by piece and then fire it off all at once. Yeah, and it's just essentially, so you can see this is where this is where readable variables start to help us out.
Oh, I guess technically that should be a modification.
Yeah, that's okay. So cryo wave here gets passed to this next thing. Hand position gets passed there. So these two are essentially functioning together. Yeah, it's more human readable. He could actually, it could be technically more compact. And we could do this by doing something like this, where we take this and instead of having the variable, we could type that there. Then we could grab this whole statement here, replace it in pan position. Likewise, we could replace sine os here with sig. And technically, it's less code. And we could, there's this idea of nested structure. The problem is that this is harder unless you really understand these functions quite well. It's, if these start getting really big as statements, it's going to get hard to follow what's going on. So technically, this is more compact in some ways, and we can do it all on a single line. But again, it's less human readable, and that's the reason for using the variables. Absolutely.
I have a few questions at the top of it, but you could go over those after.
I'll leave it open and we'll come back to it. Yeah. Fletcher, you joining us out there in the ether? Do you have anything to say?
Yeah, I'm here.
Cool. Anything to add on this?
Not really. It's not much.
Cool.
Diddled around with it.
Great. Beautiful. So what's going on here? Anyone want to try and dissect this? Yeah. So we have some additive synth going on right here. So we have additive synthesis going on, but we also have in each of these three signals, we have frequency modulation going on. Technically. Oh, no, not really, because you're right. Because this is so slow, we're just driving three signals from 20 to 100, 40 to 200, which is going to change the way it's going to go down first rather than up first. 160 to So it's just three additive synthesizers, three sine oscillators adding together that are moving in tandem at the same rate. It's a really beautiful texture. Yeah. So you could, but what would we have to do to make that happen? So if we did this, and then we wrapped each one in a set of curly cues to make them a synth and hit dot play. And then grab those three lines, we're gonna get the same effect. Now we can, yeah, so you can hear it. So here, this one goes down first since we've got a negative frequency. Yeah, Bearcat. Is there a reason why there is here? If we didn't have this, it'll still play. We have to highlight everything manually and it'll play. However, if we try to have my mouse here and I just try to play, it doesn't see any clothing parentheses. So the reason for those, notice the super collider marks those in red. Yeah, it essentially shows the super collider that we have an encapsulated function that we can then execute. We could likewise hear these individually by commenting them out. Oh, of course, because I would need to. Well, we could also just replace each of these with nil, I believe. Yeah, nope, or 0. We wanted to hear them individually. So, Cole, did you hear what you were trying to listen for?
Yeah.
AR's audio rate. So again, in audio rate, oops, hold on here. No, okay. Sorry. So in audio rate signals, let's say we've got a 1 second long, and let's say we've got a sample rate of 8. And this is 1 second. We're going to have a individual sample 2, 3, 4, 5, 6, 7, 8 at each point in that 1 second. And that's going to equal sample rate of our interface is equal to audio rate. Control rate, or KR, is going to create, depending on what the block size is going to create one value for maybe like every 4 values. And so it reduces CPU overhead by not having to make as many calculations. If a signal 44,100 is CD quality audio rate, sample rate. DVDs and film is at 48,000. We have doubles of both of those for higher quality. Super audio is at 192,000. Most interfaces have the ability to go from 44.1 kilohertz or 44,100 to 96,000. Some allow you to do 192,000. So in this case, Cole, because we're driving frequency values below audio rates, so at this frequency of 0.05 hertz, we only need to calculate values. We don't need to calculate values at the same, granularity or whatever as an audio as the sample rate. So we can save some processing overhead. Now, this is a really simple example, so it doesn't cause us a lot of issues. But if it was a really complex synth, or we had 1,000 of them running, we might need that extra CPU overhead. And so that's a way that we could optimize in SuperCollider to give us more of that overhead. We could absolutely put AR, and it's not going to change the quality of this at all. The problem is, what'll happen is KR is nice for saving for optimization and saving CPU overhead. Sometimes you'll run into an instance where something sounds crunchy because you use control rate and it's processing at a high enough frequency that you really should be an audio rate. Or if it's a direct output signal, it's not going to sound good. Yeah, it's at such a low frequency, it doesn't matter. If we were, let's say we were at, I don't know what this will sound like, 100, 100. So keep that in your mind. Yeah, at this point, it's fine to do either. It just depends. If it's a signal that's going to end up being either modulating quick enough that it's going to need to be calculated at audio rate, or it's a signal that is going directly to the speakers. In this case, we're just modulating frequency value. There are instances in which I've used AR-based modulation at frequency because I can hear the issue with KR, but in this case, we're not. So, sorry, that's a poor example. Probably confused you at the end, and I'm sorry. I want to sample at every sample. I want a calculation at every sample. I only need you to make a calculation once per 4 signals, or per 4 samples. So in this case, SuperCollider is only having to do, it's just making one calculation for 4 samples, moments in time. Whereas if we were trying to calculate the signal at every moment in time, that starts to bog down our computer. Audio rate is saying, give me a new value calculation at every sample, according to sample rates. Well, right now we were saying our sample rate is 8. If our sample rate was 44.1 and we have a signal at audio rate, here we're saying, give me a new sample or calculate a new value for me at every sample, which is going to be equal to 44.1 kilohertz of samples and calculations. Whereas if this is control rate, and I can't remember, I think the block size is 512. So this one, oh, sorry, right here, is going to say, give me a sample every 512. Give me a calculation every 512 samples. So whatever 44,100 divided by 512 is the number of calculations you'll do in a second. Yeah, that's exactly it. Things in which you don't need that same precision. Yeah. In this case, 86 times a second as opposed to 44,100 times a second. If we have to do 44,100 calculations, that's a lot more than 86. For low frequency stuff, if it's going to the speakers, it needs to be at audio rate because we still need to calculate a sample for every moment. But if it's affecting, if it's a signal that's just going to affect a parameter of an audio signal, we can calculate it at KR. Like control, like oscillator control. Or mouse, we don't need to get the mouse value every moment equivalent to sample rate. We can get the mouse from the screen 86 times a second to be sufficient. And it just saves overhead again. This is a great point. So if there's any other confusion, I'm happy to stick here for another moment.
I don't know why. I don't do all the numbers. Because I understand the concept in the but I can't seem to compare them. So you're saying that the audio rate basically the pitch is basically you're building a pitch no, kind of like if you have like a sine wave that's 44,000 times or 44,000 times, right? And every one of those pictures is going to be so it's changing and updating. Like it's like if it's too much. Oh, my audio rate is 7 bit. Oh, audio rate is we're gonna build the software and we're gonna use the audio
Sample rate of the system.
check it. It's sort of checking the audio rate instead of the instead of like a control tune.
So sample rate and audio rate are going to be equivalent. So if we say create a sine wave for me, at audio rate, and let's say our sample rate is equal to 44.1. How many samples are we going to get out of this unit generator? Per second. However, sinos dot KR, and let's just look it up really quick. I need to make sure that I'm, so here, let's go. There's some information about it somewhere. I think under URS. Well, here, let's open up this, and we can just tell us a little bit. Oh. Okay. I was hoping to have that. So. Search. The block size is 512. I remember. Well, I think it is at block size. So it's essentially, again. Oh, I deleted my thing. Sorry about that. Let's see here. Do I have back there? So 44,100 divided by 512 is equal to 86. So essentially, we're going to create 86 calculations per second for that sine oscillator. Essentially a different sampling rate. You can imagine if we're creating, if we have to put out 512, if we have to calculate 512 samples, the computer actually has to do 512 calculations, right?
Oh, so all this is doing is affecting the way that the computer.
It's essentially affecting the number of calculations that the computer has to perform. And if we can reduce the number of calculations that the computer has to perform, we increase overhead, or we don't hit our CPU as hard. You want to use control rate on signals that are not either at audio rate or signals that are or signals that are not going to be sent to the speakers. If we, here is the example. Let's clear everything up. And that's our AR 200. And now, will it let me do this? I'm not sure. So, for the var sig, I think it'll let me. I'm not sure if I can't remember how to force a control rate out of the speaker. So that's my moment. Channel rate bus 0. That's not like that. So we'll go sig K to A dot AR. So you hear this fold over and these side bands. We're essentially taking, let's do this actually. Sig left, right. Oh, sorry. Sig. Calculation every 512 seconds. So it's creating, we're quantizing it down, creating essentially dirt in the signal. Anything you want to hit the speakers, essentially. Audio. Yeah. Whatever the sample rate of the system is, which is variable, of course, based on the interface, but. Yeah, actually, I'm not trying to push you into something that you're just trying to say. Does it feel okay? Yeah, I mean, when we try to hear something that's calculated way below sample rate, we start to create dirt in it. We're getting distortion and quantization errors. Cool, great. Okay, save, next, these are great, great. Pleasure. Next on to Sam. Sam, are you with us in the ether?
Yeah, I'm here.
Do you want to say anything about this?
Not really. I don't know.
Cool. Let's hear it. Cool.
I just realized I have parentheses and on line 11. I don't even know. I was wondering why it wasn't working.
Okay, that's looking fine.
Oh, there, it's on the line 11. There, I have parentheses like right after the 500.
Oh, it's not supposed to be there?
No, I was trying to make like all just that one parenthesis right there. Yeah. I
And we're
don't.
missing
Oh,
it somewhere else.
oh, I don't know then.
Yeah, okay. Still interesting. So we've got frequency modulation. And what's happening here is we've essentially got a bunch of extra arguments that aren't getting used.
Yeah.
So these are just extra arguments again that aren't being used because
Yeah.
line oscillator only takes 4.
Oh, I was
And
trying
then,
to see if I could take more.
Yeah. Say again. Because this is just setting frequency. So we're setting the frequency value at control rate, but that's not the actual signal that's going to the speakers. And we only need to update frequency at that lower level. Yeah. You hate this, don't you? Just play around with it. Know that your code's going to work either way.
Yeah, I was just playing with it. That's why it looks really messy.
Oh, it's great, Sam. It's great.
I went into the UGens and tried looking at some of the things that I could put in there.
Yeah.
Yeah.
I think
That's the Synos KR thing right there. That's what I was looking at.
Yeah, so that's essentially, we're saying there's a frequency of 0.2. So we're going to cycle through this every 0.2 seconds. We've multiplied by 200. So we're now going from negative 200 to 200. And then we add 500. So we're then going from 100 to 600. So that's our frequency. So Bearcat, does that make sense? So the frequency is going up and down from 100 hertz to 600 hertz. And again, Sam then has just reduced that down to 0.5 linear multiplier scale. So essentially a little more than over half the volume. Yeah. If this was KR, it would not work. It'll give us a big, long, angry error. Because it's too little information. It says, I don't think you want to send KR out. That's why in order to do, like, that's why before, in order to send a KR signal out, I have to say, don't worry, I know what I'm doing. I'm going to take a control rate signal, I'm going to make it audio rate, and we'll send it to the speakers.
Oh, that sounds so weird.
Yeah, right? Well, control rate operates at that block size. So it's going to necessarily be 86 times a second or whatever the block size is. Yeah, cool. Thank you, Sam. Hanny, thank you for submitting your sketch so early on in the process. Yeah. Anything you want to add to this? Yes. So Danny's creating a frequency array in the same way that we did last week. That frequency array that is being passed to sine oscillator. And then we're mixing it. Okay, so then we probably actually want because then it mixes them all down before we send it to pan. When we have it reversed like this, we're panning an array, which has the effect of mixing it. I believe actually this would be superfluous, but not like that. Oh, I ran out of space. Let's array size 3%. Cool. Oh, not like that. So we do need that mix. That's interesting. It doesn't seem to matter which order of operations it's in. Sounds great though. Nice job playing around on that. Yeah. Any kind of input. Yeah. So mouse X right now, -1 to 1. We could do sin os dot kr of a frequency of 1. We could do LF noise 0. Linearly moving around. We could do something like line.kr. We'll review this one again where we go from left to right over 5 seconds. So any input there can be used to drive the pan position. And again, this pan position isn't getting used in our graph until we get down here for our actual pan UGen. Yeah. Anything you can bring in as a signal. Yeah, that's exactly true. Yeah. Yeah, well, they were dealing actually with 8-bit sound, but it's the same kind of stuff. They were dealing with 1 or 2 digital oscillators that were typically either set up in amplitude or frequency modulation. And so a lot of these, like, this is like the bleep blap region that we're in right now, right? Like this is very classic types of synth sounds. Yeah. Okay. Other questions that we want to get to? So what is SIG doing in this case? And if that's a rude question, I don't mean it to be.
Oh, no,
Yeah. So yeah, go cool. It's just a variable. So it's helping us out with our signal flow. So we could have this be called anything. This could be Charlie. And then we could say Charlie, 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 Charlie. You get the same thing. Yeah. Then you're able to use them within the scope of the synth. Yeah. So within this curly Q brackets, once we've declared these, we can utilize these variables to store either static information. In this case, Danny's storing just a static integer of 375 and using that to create an array from it. Or we can use it for, okay, so let's actually rearrange this a touch. So array size this is just a static single integer. Frequency array gets set here in line 8 and ends up being an array of 375 floats. So decimal point based numbers of some sort. So this is an array of size 375. We're not using outsig anymore. I apologize about that confusion. Pan position here gets assigned here in line 8. And so now that's just a signal. It's a control signal. And we're passing reference of that signal to the position of our panning unit generator. What gets really confusing, admittedly, is our use of the variable sig. And so we actually assign an audio signal in line 13 to this variable sig. We then reference that audio signal and overwrite it in line 15. We then reference it again and overwrite it again in line 16. Because when the computer compiles this synth, it just recognizes this as a namespace and it goes from top to bottom, creating something that's known as a synth graph. And inside of our synth graph is the signal flow for this synth. And it's not in human readable code. It's in machine code that's optimized for SuperPlayer. So the use of the variables is purely for our understanding. And the program sees that, okay, well, you've got a sine oscillator, and it, just like before, like let's say we took this here and copied it. Don't move anywhere, program. You're not, it's fine. It's totally fine. So it creates an array of frequencies of 375 for the moment. We're just going to get 200, 201, 400. And we can do away with that. It then takes this sine oscillator and it plugs it in place of where sig is. It then takes this output and signal and plugs it in place of sig. And then we've got one more variable, pan position, and takes this pan position and plugs it in place. So it just goes through the program like that and creates essentially a synth graph from inside out or top down of signal flow. So the variable names, we could have also something that some people do, which is totally legitimate, is sine, yeah, we do like sine sig hand sig mix sig. The next one of these. And then again, we'd have to replace sig. Oh, and I've got one error somewhere, but oh, missed him. What is my bad? Not in this IDE. Let me get back to you on that. Does that feel a little better? Yeah, and this is some of the discomfort still with a text-based coding environment and just the flexibility of variables. Yeah, absolutely. I'm not worried about that at all. Okay, and while I pull that up, Matthew, what was your question?
So if I want to change the mean variable, but I've used it a lot of times within that
So,
yes,
fine. There's a way of doing edit. Command R allows you to find and replace everything. Now, this is where, quite honestly, there's an ability to use something like Atom or Sublime or other text editors as a front end for SuperCollider, and there's advantages to that because these text editors are better at allowing you to quickly select multiple words that are same, find words, move text around, whereas SuperCollider is not the greatest text editor. However, it's easier to stay in the SuperCollider environment at the time being for its other functionality it offers, like autocomplete and such. Yeah, you did some great stuff here, though. Okay. Let's see here. I just want to see what that error is. We're going to get to dust today. Rlfp is a resonant low pass filter. So it's got that kind of bump on it at wherever the low pass cutoff filter frequency is. Nice low frequency. Another nice low frequency. Another nice low frequency. What was the error? No, I don't. Let's find out. Let's try to find that. 12, yeah, that's exactly where it is. So you can hear at 70, it's still same amplitude. And then we start to get a drop off as we go lower. I'll bring the sub in for future weeks. Oh, it actually might be 80. Yeah, so typically speaker specifications or microphones, when they mention their usable or their frequency range, that's wherever, like let's say it's 70 hertz to 20,000 kilohertz. It will still make sound below 70 hertz. We'll just see an attenuation of the power that it has at those lower frequencies. Cool. Okay. And what was your question earlier, Matthew?
Oh,
Oh, great. What other questions do people have?
oh, I guess I have this.
Okay, first off, nice job, Charlie. Really excited to see you playing with Dust and Resonant Low Pass Filter too. Those are some fun things. Yeah, man. That's okay. That's all I do in Touch Designer still. Yeah. Jared. Yeah. You want to send it to me? You want to airdrop it to me? Okay, everyone, I should be turned on for you to drop it to me. These technically? Well, they're lying to us. Thank you for finding that. Are they? Yeah, they're the K8.2s. Yeah, interesting. Yeah, I mean, they're doing some digital signal processing to optimize that. But, okay, Jared, what was the problem you were saying here? Mouse X, range 200 to 800. Now the problem 0 to 1. So I think this is, we're going to run into an interesting problem here, and we'll talk about that in a second. So we're getting an error. This is a great example of how to solve this. ADSR not understood. On shape dot ADSR. Ah, so that needs to be on dot ADSR. If you tried to open up help, so Command D on the method ADSR, it shows you the only unit generator that we can use is on. In this case, you were just replacing the variable on shape, and it wasn't sure what you were referencing. Let's see what that does. So 3, what's it do? Outside. Interesting. So, what were your thoughts here? Because outsig isn't going to anywhere. Yeah. Cool. Well, I'll let you keep playing with that. Send it to me at some point when you finish it up. Cool. All right. Any other outstanding? Oh, we got a couple questions from Matthew. Let's see what they are. Is this a question? Why do we plug on into OnGen? On, great question. And we're going to go over some of this again today. But on just creates an envelope specification. It's not a unit generator. Come on, don't do this nonsense. So come to the top. Env is, come on, go up. So env is an object. In ADSR, env.ADSR creates an ADSR object. But it doesn't know what to do with that object. It's just like some sort of shape that it's created. OnGen takes that object and creates Why are you not letting me go?
Generate.
Creates a unit generator. So it creates an in-time relationship signal.
Often not create the envelope itself.
Does not create the envelope itself.
It can only generate previously specified.
Exactly. What? An envelope is what is an envelope in the real world? For anything. In mail, an envelope contains some sort of letter or bullshit or whatever, right? So an envelope in audio just contains something, it contains something else. Typically, we think of amplitude envelopes. And so if we've got a full scale amplitude and we wrap it in this envelope that's specified right up top, we're going to get we'll multiply by 0 all the way up and then down a little bit, and then we'll hang out there and then multiply back by 0. So you can kind of see that envelope essentially contains the amplitude of the signal. That feel okay? So an envelope can contain any signal. Now, typically envelopes were just used to specify amplitude. In this environment and on most modular synthesizers nowadays, you can use an envelope to affect almost any parameter. So that could be frequency, phase, anything that we can affect over time, we can encapsulate with an envelope.
It's kind of like a streamlined way to, there's a kind of streamlined way to modulate the null value. Pretty much.
Yeah.
So you think that the envelope is a way of grouping things together that you're going to affect in a singular way.
It's a way of creating some sort of specified change in a signal over time. An envelope allows us to say we want to go from 0 to 1 in 1 second, from 1 to 0.5 in 1 second, hang out at 0.5 for a second, and then go down to 0 over the course of a second. There's no other way to specify that without the use of an envelope.
Oh, I see. So it's like a collection of
Points. Yeah, so you can think of it as a collection of data points. And we turn those sets of data points into a signal over time.
Okay.
Explain what can go into the function brackets for dot collect. So if we wanted to figure out what can go to the function brackets for dot collect, we can go to help on collect. We see it's an array. We'll click array. Maybe my thing will work. Maybe I need to. Cool. Go to array collection. Wow. My help though is being super weird. I need to rebuild SuperFighter. Yeah, so there we go. So answer a new collection, which consists of results for the function. So it essentially just creates a new list from whatever you tell it to do. We can pass it an array already, in which case it'll iterate and do something on each of them in there, or we can pass it a number and tell it to create a new array from that information. Come on. Go away. I got too much going on here. Oh, yeah. So all of the SuperCollider help documentation also exists online. For some reason, if it's glitching out like it's doing right now. So an array is an arrayed collection whose slots may contain any object. So if we look for find collect, find dot collect. Answer means create a new collection which consists of the results of the function evaluated for each item in the collection. Does that make sense, Matthew?
Yeah, but what exactly? It's I like how the things try to do how it's like a key sign off.
No, but Supercolor tends to do that primarily for unit generators and functions. So a function is anything, come on, that's between curly Q brackets. Ends up being a function. So we say our val1 val1 plus val1
But how do we? And do we have to have curly brackets in the dot left?
yes.
And so I mean, okay, I did just like 4 dot left and then 4 nothing.
It should just do that, I think.
It's just giving you nil.
Oh, then you haven't passed in, so then it's just passing back nil because it's not doing anything.
Okay, so what is it that I'm supposed to do?
If we did for.collect, and we said array is equal to for.collect, we'll pass it a function. This function gets IDX and value. So we can go IDX dot post line, val dot post line, and we'll just go okay, and we'll execute this. So notice I get oh yeah, it doesn't have, it's whatever, because we're just doing the number, so we don't have a value per se. But we're passing IDX is 0, 1, 2, 3, and we get back an array that's just a bunch of nils. Because we haven't passed anything onto it yet. So if I just pass IDX, 0, 1, 2, 3. So the last thing that's passed as the value to the array.
So, and why are you specifying?
Just so that we have somewhere to store this array for the time being.
Okay, got it.
I could do this like this and not execute the global variable, but then we have nothing to reference it later if we wanted to.
So for that collect, not specify an or
What do you mean?
so when you go into dot collect function brackets, you just specify I mean,
This function gets handed, sorry, that's a great question. Okay, what does a function do? For everyone who's, let's just make sure everyone's feeling clear about what a function is. Yeah, it's an action, it does something. No, we could have a function that has lots of, so in this case right here in lines 5 through 8, I'm defining a function. We've got a value that gets passed in as an argument, and we'll post value 1 plus value 1. We'll post that out. We've just defined a function. So now A,
oh, I guess.
so A is just a function, doesn't know what to do with it. In SuperCollider, to execute a function, we type value, and then we can pass in any arguments. So if I pass in 5, we get back 10. Yeah. So let's say we define another function. We'll call it func. It's just hello everyone. So I've defined a function. If I execute this, it tells me it's a function. If I pass the method value on this function, what's it going to do? It's going to run the function, and it's going to post the line hello everyone, because that's our function tells us to post that line. Just like in the synth, when we pass the play method to a function, the default output is the last statement.
Okay, so are you saying that in 14 when you say 5, is that changing the argument value? Or
It's passing in a argument with a value of 5.
okay, but is it replaced with value?
In this case, we're defining an argument to pass in for our function. This is a great point here, actually.
Because in my mind, I would see that the only way to do that would be to use a backslash and change value to set value 1 to 5.
You're thinking for a synth.
Okay.
This is where we get confused. So when we define a synth, it gets passed. Oops, I've lost my thing over here. Sorry. Oh boy. It gets passed. Let me just reset this and see if this helps. So this gets sent to the server. Okay. So now the only way to interact with any synths running on the server is tell the server that we want to set something about them. Does that make kind of sense for everyone? So a synth gets sent to this separate application called the server, which is the very confusing part about SuperPlay. If we just define any old function, it's staying on the language side or the interpreter.
So it's a lot easier.
So it's different. It's just different.
It's obviously.
It's by itself.
The server is.
The server is the sound engine. That's where we create these synth graphs, and they get executed one time every sample value and sample rates, and it gets sent. We can bring audio in, we can send it out to a speaker. Yeah. Synth. So we can interact with both the language. I'm sorry that I'm not being more clear. I am trying, everyone. I really am not trying to create confusion for everyone. This is great practice for me, and I don't mean to be rude, Charlie. I'm really I'm not trying to leave you in a place that feels like this is odd calculus in 8th grade. But it's great. So here's some great things. We'll just back up. Okay. If I go 2 + 2, what happens? Well, yes, but what happens technically?
It executes it.
It executes it. It says, okay, we've got some math here. I'm going to stay in the language side and interpret this. And clearly that equals 4. So I'll output that to the post line, to the post window. Everything here is all stayed in the interpreter side. It did not go to the sound engine. This is called the interpreter. If I go, hello, everyone, that post line, this stays in the interpreter. That stays in the interpreter. if I create an environment variable called dir and I set it to 2, dir is in the interpreter. I can reassign dir to equal itself times itself. It now equals 4, 16, 256. This is all stayed in the interpreter.
And you can change the third one to the later on.
Yeah, so let's say dir duh, I like to write it. If we create a function that just prints something, we now have a new function. This is still all on the language side, interpreter side. Duh now is just a function. If I execute it, it tells me it's just a function. That's what's stored in the variable duh. I know. Da, dir da. So there's 3 words I like: dir da bum. And it's just how I do dir da.
So why?
You're right, da.
18 to 17 doesn't send something to the post window.
We haven't told it to execute the function. We haven't here. Dir is
Why not do so?
it didn't execute a function. It's telling us that it has the integer 256 stored in it. If I reassign dir to the integer 2, it's now stored to 2. Here I'm just telling it to reassign a new value, and we're referencing itself twice before we assign it.
It's not stored text in a variable.
We totally can store text in a variable. And then here, that's just stored text in a variable.
So if you put the curly bracket on it, what-
It becomes a function. Now to execute this function, we call the value method, and it prints something.
Okay, gotcha. And so dot value is pretty much a just an text.
Yeah.
Okay, gotcha. I think that was maybe that in some cases you need a post line. I mean, you don't get this.
It would post it because it's the last thing. But let's say we had this statement here, and then we had another string of some sort. We don't need a post line on that one either, but the only thing that's going to get printed when we execute it is string of some sort. The other way to execute a function is just with 2 sets of parentheses.
Oh, well, so if you have string below everything, you are post line, and you run that line.
If I have it like this, it will print it in the post window because it copies back the last command. If I have 2 commands, rather statement, it only prints the last statement. Then we have to be explicit with what we're doing. And that's why we don't want to leave things to chances. We should probably write post line behind both of them.
Now, in line 10, you set 2 when you observe, would it just say that it's a variable?
Say that again. If I set dir to what?
So if you set dir to but within function bracket, and then you dir it is a function, so you then dir dot value, and then it's executing. That can do it.
So if we get more complicated and we create a complex function of some sort,
You could do a function that's kind of just like or people call them
people think of it as a recipe. Let's think of it that way.
what is it called? Algorithm.
Yeah. Variable result So in this case, what are we doing?
So function dot one dot one two. And so, okay, so it's not specifying what, okay, so this is what I was thinking. I thought that what you were doing was changing the argument in the way that we do with the synthesizer, but what it does is it just takes your function, whatever happens to 37, just passes that in, but get a third value, it would still be true because it's not a third value slot.
Yeah. So, and this is where, for those of us who haven't taken creative coding, in a function, we specify arguments that we can pass in. In a typical programming language, come on, move here. In a typical programming language, like if we were in JavaScript or something, you might write function, or you would, it would be function would be, we would declare that we were writing a function. We would then instantiate our function name, and then we would instantiate our argument names. And then we would say, do something with args. We would execute this whole thing, and then we later could use our function. And this is what it might look like in something like JavaScript. Supercollider is based on Smalltalk, so it does things, unfortunately, in ways that feel really frustrating. So to declare a function, we simply use the function brackets to declare arguments, and arguments are, this is great, actually, guys. Arguments are values which we can later pass in to a function.
And so, this is, so what I was thinking, so maybe 38 is not actually.
Yeah.
If I do another two, and then dot post line, which gives me two,
Yeah.
right? I don't know whether it's casting one into a string. Yeah, if we does it doesn't matter. If I immediately do so it will flow goes to dot post line, and then that line keeps me below. If I run both of those in one program, it gives me an error.
You go to post line. And did you include a set of semicolons after your two dot post line? Because those are two separate statements. Great. Okay. Why are we multiplying in line 36? We're multiplying by amplitude value. We're doing brute force panning. Okay, these are going to be questions for office hours in the future. Take advantage of office hours. Okay, let's take a 15-minute break. We'll come back and we'll see how much content we can get. They are. They're Mondays from 12 to 1 and then by appointment via calendar. I believe they are also on. Oh, that's not them. Let me. That's possible. Zoom 30-minute meetings. What's today, the 8th? Ah. Busy. That's not right. I'll check this out. I'll check that out, okay? And I'll also put it on the README page. Charlie. Yeah.
So last night, I was like, shit, GLSL probably.
Yeah, except
So-
it's a much cleaner language,
Okay, well,
just to give you
So-
some reassurance.
I'm looking at some examples.
Yeah.
There's this, right?
Beautiful.
It's just like, show code. It's just that.
Yeah, GLSL box. Yeah.
And I'm just wondering,
So GLSL is kind of based on C, so it is a touch cleaner.
so how would I, like? I
So
don't even
let's
know what to
grab,
call
we can
this,
we can
but-
work through this. And we can start to practice basically. I'm gonna throw some terms that you've heard that may or may not be sleep like.
Because this, in a lot of ways, seems like, I know, like, GLSL within Touch Designer is great, but just seeing how simple this is and how,
So this right here is saying that in strictly typed languages, when we declare a variable, we declare the type that the variable is. It's not in a loosely typed language, we can declare variable and then put any value in there we want. In this one, we are saying we're declaring a variable called time, which is of type uniform float. A float is a decimal value of some sort, 1.35, 0.97225. Our next variable is a vector. I don't remember what uniform means in this context. So it's just another modifier saying that this is a variable type that's a vector, typically 3 values, X, Y, and change over time. Although vec2 might just be 2 values.
so, if I wanted to say I knew what all this meant, I'm like, yeah, I want to make this.
Yeah.
Where would I type this into to make this happen?
In what do you mean? Like how?
Like
What kind of
how-
program would you use to
Yeah,
write
how
this?
do you do
I
it?
would suggest you use a program called Atom.
Adam, okay, and I actually have that on my computer upstairs.
And so the thing that's gonna be cool about something like Atom. Now,
But
GLSL, you have
so-
to execute GLSL code in some sort of GLSL interpreter container.
So like Touch Designer,
Touch Designer has the GLSL object.
right?
And Touch Designer allows you to use Atom as an external text editor.
Yeah, because when I did that little bit of GLSL with a curl noise, looked a lot like this. And
Yeah.
then it executes in Touch Designer.
Now, GLSL, there's a cool GLSL book somewhere.
And then there's HLSL, which is what DVDV uses.
Is HL, and what's HS? H
Uh,
stand for
I'm not sure, but
graphics, something
it's kind
high
of the
performance. The book of shaders, yeah.
book
You
of
need to go through
shaders.
this son of a bitch.
Okay. I'm like just finally breaking through my fear of Super Glider last night. I was like, holy shit, GLSL. I get
GLSL.
it now. I get why.
Oh, so here, this is cool. So they have an inline code editor. So, oh my God, yeah, we should actually just like work through this together. I don't think I'm gonna do it. It's a fucking, and they've ported it to a couple different
Book of
languages.
shaders.
What is a shader? And it's just gonna tell you.
Cool.
So if you want to do GLSL, this is. the
I
book
want to
work
get
through.
into shading language because
Yeah.
I'm seeing.
And so remember we did Hello World earlier?
Yeah.
So this is the same thing. It's gonna tell you how do you do Hello World in a shading language. In this case, we're defining, I need to learn more about float, how this is working here, because I don't remember. So this is just defining a variable, uTime.
Yeah.
And then we're calling the vector. In this case, it's representing color. And it's being passed to this thing geofrag color, and that's changing the color. So that's what they consider as the hello world of GLSL.
Yeah.
Next item. So, and this would be a good book to work through because it's all free and online.
Cool.
But let's say we go to a more complex example
The
here.
book of shaders.
Local shader. And I've been wanting, this has been on my list of things to do for a while. Oh, they've only got it through a certain level. I wonder why that is. Yeah.
It's all C, right?
Yeah, let's say, yeah, it's C-based. So now if we're working in Atom, language,
DLSR doesn't work on that.
well, that's bummer.
At least there's where else could you want to. But
Let's just save this up somewhere. Desktop for the moment being. Figure it out. I think it's DLSR. And so it does the automatic
right.
coloring, which is nice.
Right.
And then I think so float. Then we can define a function name. We define our in as our new argument, arg1. It's just a matching eventually return.
This is a function because it's in clearly.
Yeah, same thing, right? Like you start to see the things we can call. So in this case, they're calling the fraction function, and then nesting it with a sign function and dot function. And then they're passing in st. So whatever argument got passed in, it's a vector. They're grabbing the XY position from that vector. And multiplying it by this thing, I think it's a dot multiplication function. So then, so we start getting the leading out, which you'll pick up very slowly and easily.
Cool. Yeah.
Or you'll ask your mom and she'll be like, no worries, let's talk about it.
Yeah. Been following this. And
Yeah, the one that
random
Cole sends?
Stuff. Yeah, and it's really helping a lot, actually.
Yeah, I'm gonna send that to the
Realize
class.
that I need like the combination of the in-person and just
Some reading.
recipes.
Yeah. And the P mention is what he's doing, and that is where you're gonna get into like the,
P-line?
and that is what allows us to kind of do this sequence-based music in the easiest way.
Right. Cool, yeah, and so some of the stuff that you do,
Mhm.
you're using the microphone input.
Yeah.
And you're basically writing effects pedals.
Yeah, you can think of it that way.
Let's see. It's like a highly volatile system. but it's
Yes, it's a highly volatile, idiosyncratic system
easily
that is prone to glitching and breaking.
too far.
All of those things are true. Why do you think my office hours are all fucked? It's like I don't want to meet with students.
Sweet. Thanks.
Bearcat, you got a question?
Comment and question.
Yeah.
One, I'm catching up on my life, so I'll get to these two.
Cool.
those few minutes.
How's that feeling?
It's not feeling well, but it's
I'm sorry.
better.
Yeah,
Um,
that's okay there, actually.
so I'll get to those 2 minutes as quickly as I can this week.
Great.
Sorry if I wait.
It's fine.
The second thing is just kind of a field, anywhere in town that I can get, HRTF file. I'm doing stuff with virtual surround sound headphones and I think
No, I don't. Of yourself?
Yeah,
You want your
of
own
myself,
head-related
yeah.
transfer function? No, I don't know anywhere in town. Unfortunately.
I know you're in the know.
No, it's an interesting question.
I'm sure they're always doing it themselves, but I don't know what they are. It seems like it's impossible to do it.
Yeah, it is. Yeah, because when I had it done, I had one of my colleagues at NYU do it for me. That's an interesting. Let me think about that. Yeah.
Yeah, I found a trove of surround sound. They're not surround sound wave, but they're wave files
Uh-huh.
that contain the
the different frequency modulations for different kinds. So you can have you can stick there's Dolby Atmos file. It's a wave file, 7.1. If you listen to it, it doesn't sound like anything. If you put it in your frequency chain, it turns your 2-channel into surround sound.
Yeah.
It's one of the,
Yeah. And I don't think we're gonna get to some about this semester, but if you want to come by office hours sometime, I will be fully focused on this question. We can talk about it.
awesome.
Yeah.
Like you're at 55 or
Sure. 55, let's say. No, that's a problem.
If you do two, is it passing that to the-
Say again?
if I just do two dot push line,
No, it's just posting it as an index or as an integer.
okay.
Yeah. Have you really? Cool.
Yeah, it was no surprise.
Yeah. Then we had a good time. Matthew, my office hours are fixed. Thanks for pointing that out.
Oh, yeah, absolutely. That's cool. What do you do?
Lots of stuff. Most of it is JavaScript.
I need to press-
Do a little bit.
Yeah, I'm trying to.
The JavaScript one about this start, which that's like, it's like 50-50 of the top versus the JavaScript.
C# is.
It's just basic C.
C.
JavaScript, Java. What's your learning? Read the code values and just read it, which the sound part can be. It's in both different waves and
Yeah.
that part I got. So it's sort of good.
Yeah. No, this is good. So how did you?
It was halfway between taking JavaScript and actually did a little bit of app development for the electrical. And me and a friend of mine, we basically learned everything that class didn't teach us in the crash course teach ourselves sort of way. So we can pretty much learn everything.
So did you go online?
Yeah, and the problem is done with the schools, section.
Which language?
JavaScript.
Yeah.
One of the schools is
JavaScript is great.
maybe longer.
It's cool. They've ported it to P5.js and some others as well, but it's best just on GLSL. Say what?
I think it's fine a lot.
Have you?
Yeah,
I don't remember. I think you have to port it over. P5 is, do you know processing? Yeah, so it's the JavaScript version of processing. And what's nice about that then is that you can create websites with P5 to do interactive websites
I took the very, I had your last year
before it got changed up.
I think if I wouldn't have started with that, I think I would have been much more confused. And as some people that started with straight JavaScript, like I hated it. I learned this, and so I made unicorn and stuff in
Yeah.
class. And it was much more fun.
Well, and I'm not sure, I don't think he's going as far in P5 as it used to, because he's. It is a web-based application, and essentially it's a, how would you, it's like a playground or like a fenced-in version of processing. Yeah. That's a horrible way to put it, but that's exactly what it is. Yeah. And the nice thing about it then is it, because it's all web-based, it's immediately ready for the world to see and interact with live. There's no porting and there's no trying to like render out something that you then have someone download. It's just on the web. Oh, yeah. Really? That's so cool, Maya.
Me and Claire, she's graduating.
Oh.
She's in Texas. And
Is she really? Bet she's back in Texas, but you guys are doing this. She's doing it remote. Yeah. She did that audio one. That's really awesome to hear.
we cannot stay apart from each other. So
You guys are doing some great work together, though. Yeah. That's great. That's super cool. Hey, Cole, come back. Where are we going? Okay, so. Fair, cool. Cool, man. Get it in you. Okay, I'm gonna reopen Superclutter because it's being glitchy. I don't know why I need to recompile it. All right. So, impulse. All right. Whew, we went through a lot this morning, a lot more than I thought we would, but this has been good. Hopefully people are starting to feel a little bit more comfortable. Again, I recognize the difficulties of this class in that we're coming from a fuck ton of different backgrounds, and that is super cool. All right, what the frig is a unit generator? Sure, who else? A unit generator creates a signal, essentially. That's how we're going to think about it. A unit generator creates an active signal in groups of units. Fuck that. That's a horrible name. So it's just though it creates a signal or it modifies a signal. It does something with the signal. Okay. Yes. If you're thinking of modular synthesizers, you can think of it as a module, like a equalizing module, filter. Yeah, exactly. Or an oscillator. So in this case, we're looking at an impulse oscillator. And this is, I want you to start paying attention to some of these things up here. So unit generators are classes. For those of you who haven't gone through creative coding or more formal CS background, a class is essentially a description for how to create an object. An object just does something once it's been created. Oh, I hate the way that sounds. But in this case, a unit generator class creates a unit generator object. That unit generator object then can either affect or create signals. In this case, typically we're thinking audio signals. Impulse is part of the generators and deterministic generators. If I click generators, we'll have some unit generator options. If I click deterministic, notice Synos is part of this same group. What does deterministic mean to you as a word? How is it different than indeterminate? In this case, determinant We're gonna actually, yeah, we're gonna say it's periodic or regular, or there's no randomness. That's not thick enough. No one can read that. Man, I don't know what's going on with the O. No randomness. Yeah. So deterministic means it's some sort of periodic. It's something we can depend upon. A sine oscillator is always going to be a very periodic sine wave. Let's clear this out. If we look at chaotic, no, let's look at these are all Eugens. So notice LF noise. Oh, LF LF noise. Oh, I have it selected. LF noise. Oh, still not selected. Whatever. LF noise is part of the stochastic. Deterministic. Oh, no. So stochastic, randomly determined, having a random probability. So LF noise creates random values. So it's part of the stochastic grouping. Deterministic is going to create some sort of predetermined patterns that we can follow. So let's go back to impulse. So impulse oscillator outputs non-band limited single sample impulses. So if we've got a signal, every periodic amount of time, it's going to do a single sample that is at 1. Makes sense, kind of? Okay. So let's listen to it. Again, if we're in help, we can actually listen to things, but I'm going to write it myself. Impulse. Return. Let's clear our, well, we'll leave that there for that big. So, we will do impulse.ar in audio, and we're going to do a frequency of mouse x.kr, and we'll go from 0 to 200. And we'll pull it. And we're going to drop our mole so that we don't blow up the speakers, because this can be really hard on speakers. Mole is a multiplier. So, yeah, if we've got a signal and it goes from +1 to -1, and we multiply by 0.5, what's our new range, Cole? We're now at +0.5 to -0.5, cutting the linear amplitude in half. Now, our perceived amplitude would be cut more than in half, because linear and decibels don't match up, which is a problem of this language to some people, but just know that that's the case. I can't clear out of this nonsense. If you multiply it by 10, you're going to blow up everything. If you multiply it by 0.707, it'll match up. At any rate, okay. Oh, boot my server. Let's open up a meter. And let's open up a scope so we can see what's going on. Okay, so we're at a frequency of 0, so we have nothing going on. You hear the pulse at a frequency of 1.6 hertz. So essentially, we go to 2, twice a second, we hear a pulse. We can kind of see it. Jared. For the envelope generators and stuff? Yeah. That's why we're introducing this now. So what happens if I keep going up? We start hearing more of it, right? Well, at some point we hit eventually it starts sounding like a frequency. There it sounds like 181 hertz. One other thing I just want to play for you right now, or show you, is show freak scope. This is just a frequency analyzer. You can see it's all frequencies technically. Now we're starting to get harmonics based on it being within the human hearing range. Looks really neat. Just super old school looking frequency analyzer. Love it. Yeah, cool. So impulse, again, just goes from 0 to 1. All right, cool. Dust is random impulses. So notice it's part of the stochastic group of generators. So let's take this same block of code here. Fantastic. Damn it. No, staccato in Italian would be short, but yeah. Stochastic is a mathematical probability. Yeah, great question. Creates a periodic sample at a value of 1. So these are not regular, right? They're not periodic. So it doesn't result in something that sounds like a frequency or a tone to us. It results in something that sounds like noise because of the quality that they're shot off at. Okay, so these are two. And then another one to be aware of is probably blip, which is another deterministic UGen. Different from impulse in that it is band limited, meaning impulse is sending out every frequency from 0 up, etc. So we're going to get fold over and aliasing and distortion. Blip actually filters out everything below 20 and everything above half of the sample rate. So if we have a sample rate of 44.1 kilohertz, it filters out all frequencies created by blip above 22,000. Yes. Yes, impulse is like a white noise signal, but in instantaneous time. And that's because if we go from 0 to 1 on the timeline, it essentially is all frequencies. We're not going to get into the details of that because that actually goes into DSP land. So blip has a nice quality to it. Impulse is not band limited.
But it's not band.
Blip, yeah, because it's being filtered. Yeah. And so it creates some hard artifacts out here. Oh. Band limited just means that of the frequency band, you're limiting the top and bottom. Of a band pass, or not a, but a, yeah, band pass filter passes a band of audio specified by a low cutoff and a high cutoff. In this case, the cutoff is at the ranges of specified by sample rate, typically 20 hertz to 20,000 hertz. That kind of makes sense? Yeah. And the reason why we have to do this is in digital audio theory, when we go from 0 to 1 in no time at all, that's called an impulse. And that is theoretically all frequencies at once. And that is how you can tear apart speakers. Super collider is great. If you really want to go destroy someone's speakers, super collider is the way to do it. Same with eardrums, headphones. Yeah, sense of musicality. Yeah. And that's why we don't have the artifacts, because it's not having to work so hard. Now, technically, that's all frequencies. Does it actually end up sounding like all frequencies? No. Is it super hard on your speaker? It's super hard on your speaker.
That's why it's not tied.
Yeah, because we don't have enough time to really activate the entire speaker.
Or you can get a whole sine wave.
Full cycle. Yeah, that's exactly it. So these are really cool in creating noise effects. Great for noise effects. Single sample moments. Or being used as triggers for envelopes. Okay. So what is line again? Does anyone remember? Straight line, yeah. That's exactly it. Let's clear out of this drug activate. We go from line dot kr 0, 1, 1. It's going to go from 0 to 1 over the course of 1 second. Cool. So simple. How can a line have a multiplier? It just can.
What is that?
It's going to multiply the main output. So if you multiply 0 to 1 by 0.5, it's going to go from 0 to 0.5. Okay. That's why mole oftentimes gets us in trouble.
But it's changing the thing.
Yeah. Yeah, that's exactly it. So sig, we'll have sig and on. That would just shift it up or down based on the value. No. Yeah. So let's go from 0 to 1 over the course of 1 second. Oh, actually, let's go from 1 to 0 over the course of 2 seconds. And let's just look at help on it so that we can see it again. So start and duration. And then there's this thing called done action that we're going to ignore for the time being. black box, signal is equal to sine os.ar. Oh, let's do something else. We'll do white noise.ar 0.7. We'll multiply that by on. Oh, I got some extra. Use circuit. Okay. Cool. Is it back? Back. Okay. So again, we've got an envelope defined as line. We can also remember if we wanted to see what that line looks like, hit the dot plot method after it, highlight only that. Oh. And it shows us 0, 1 to 0 over the course. Oh, plot duration 1. So we can, yeah. So that shows us that. Or we can also do, what's the other thing we can do? This is the one I always forget. I guess it's subplot, but there's another more eloquent way to do it. It's whatever. Doesn't matter. Okay. So in this case, I get you, Bearcat? So we have white noise. I went from 1 to 0 over the course of 2 seconds. I'm going to do it again. Yeah, right. Cool. All right. And you can hear that linear nature. X line. Yeah. So we can change. Sig will be set to sine os.ar. And here we'll go frequency is equal to on. And for on, we'll go from 100 to 200 over the course of 2 seconds. Mole 0.7.
Also use it. Also use it in the envelope too.
Yeah. So what you could do here, let's say we go from 0. It's okay. We can go from 0 to 1. We can say dot. I think we can do range. It's going to know what our input values are anyway. So then we could say 100 to 200, and then we could still say because we're just putting some maths on it. Cool. So this is a parabolic line. And here we'll go X line. Oh, that didn't work right. What am I gonna do right there? That doesn't make sense. Oh, you cannot pass 0 into a parabolic because you can't pass 0 into a quadratic function. You get an error. This goes back to some weird high school math stuff. So if we go from 2 to 1, and then we go range from 1 to 0, right? And if we extend that out for a lot farther, I think you're right. Yeah. Because I flipped it with range. Yeah. But now if we go, whatever, if we go from 100, 200, that's a more natural progression of frequency. So just know that you can create a parabolic curve using an X line. Not in X line. Not in X line. But there are other ways to do that. Okay, cool. Linen. Creates a simple linear envelope. So let's, we're going to ignore the help files here because I don't like the way they're written out. Huh? So we'll say variable sig envelope is equal to linen.kr. Gate, we're going to use impulse.kr. Time value just equals 0.5. We're going to call this gate. So this is one method I like to do sometimes. Attack time will keep as 0.01. Sustain level we'll leave as 1.0. Release time, we'll just set the 1, yes. That's the frequency in hertz. So that's essentially going to be every 2 seconds.
Oh.
We are 1. I think we can do it this way. Not. We'll do impulse. So this is the curve we're getting, the envelope we're getting. Can you all see that kind of that? You can see it's a really sharp, yeah, really sharp attack. It's straight up and then it comes down. So again, over 0.01 seconds, then 1.0 for a release. I am not, I've been trying to get Sidecar to work. I'm using a different app that I used to use before Sidecar came out called Astropad. For some reason, Sidecar doesn't let you use non-Apple pencils. So same idea. Is it working okay? This at least getting to see it on the board. It took me 3 weeks to remember how to do this after not doing it for a year and a half. Anyway, thank you for noticing. I appreciate that. Okay, so if we clear this out, so this creates, linen is a simple attack, sustain, release. Release envelope. Requires a value above 0 to what do you mean? Like how often it's occurring?
No, I mean like the sound itself.
Linen right now is what is linen affecting? Anyone? Which envelope? Linen
Oh, of the sine os.
is
Oh,
affecting the
okay.
amplitude of the
Sorry,
sine
I
os.
see that down. I thought that was also opposite, but
I can,
the lineage was
if,
non-envelope.
yeah. So I could say attack level or attack time is 0.1, sustain level 1. Times on plus 200 or something like that. Or dot range. And we could say we want a range of 200 to 400. Just whichever you want to use. I mean, it's like any programming language, there's multiple ways to do the same thing oftentimes. Yeah. Linen is one that exists there, yeah. And likewise, so if we had something like dust instead, okay, and then I forgot my whole thought here. Oh, wanted to see if we did. I think I can do this also. Mouse X dot KR. We go from 0. Oh, just because sometimes you notice how we don't get a true 0 when we have 0. As long as my value is somewhere below 0, negative 0.1 even. Notice that as long as the gate is above 0, it holds it at that top value. Well, if gate is open, then it stays at sustain. Otherwise, we're not engaging sustain. And as soon as we go below, gate closes, our release time gets activated. Does that make sense? Well, here we do the attack, and now we're at a sustain. Our sustain level is at 1. As soon as I go below 0, you activate the release. What's your question, Matthew? As soon as it drops below 0, we get the decay. Sustain is whenever it's above 0, sustain is active. As long as the gate is open.
But obviously, it's not stopping the entire thing.
The gate is being applied to the function of the envelope. So if the gate is open, great question. If the gate is open, if open, Sorry, that's some piss poor writing there. Then we activate our sustain level. Once closed, activate our release. You can think of it also just like a trigger. It's just an if-then statement. If it's above this, then we keep it the sustain level. As soon as it's not that, we activate our release. If our release time was something really short, like 0.01,
So you're talking one of our things is saying that the frequency of that oscillator is whatever the envelope is set at. And then you can-
Yeah.
Or in that sense, when you're speaking to it.
yeah. But we could also just replace this. Or we have this applied to and we'll go back, dust.kr. Set this at 200. What happens if I do that? Anyone know? How do I want to make it loud? I want to turn up my volume on my controller.
So what's happening?
Yeah, my amplitude has to be higher. Well, so here's the thing though. Okay, then let's say we've got -10 to 10, right? Whatever. But why does it sound like shit? Yeah, why is it clipping? Because I'm going above 1. 1 is max volume.
Oh.
We're in a digital system. Amplitude is all relative to max. Amplitude decibels are all relative to max.
Yeah.
1 is max. Anything above 1 is clipping. If I want it to go louder, I just need to turn up my fucking volume.
Yeah.
Does that make sense?
I guess I was trying to figure out.
If I want the attack sharper, then I want a shorter time.
Yeah, over time, and then probably. And
Don't have to. That's going to affect the max level. Based on release time. So if I had mouse X in here, -1 to 1. I've got this value.
but it's not gonna decay until it's.
Yeah, Bearcat.
I
Cool.
don't understand the relation. Something is the same until it's released. So there has to be a relationship between sustain level and the release. I don't know what that is.
Interesting. So, great question. So fundamentally, we're setting up an envelope that looks like this.
Just to get all sounds in the universe.
We can decide, we can actually define all sounds, including my voice, by a series of envelopes over sine waves.
So it's,
Yeah, and envelopes can be incredibly complex things.
I'm not a music tech class, and that class is about how your immediate thoughts and sounds like impossible to identify.
Yeah, but that's because attack sounds also include a lot more than just the basic sine oscillator. They oftentimes include noise and other non-harmonic overtones. So that's why those are incredibly important. And also the decay is incredibly important in determining perceptually what sounds belong to. So if we have, so Bearcat, if our signal is greater than 0, then trigger. Does that part make sense? If our control signal. Yeah. So if it's above 0, then we go up, think from 0 to whatever our sustained level is. As soon as our control signal is less than 0, then release. I can't have room on my iPad to write it out. So at that point, then it drops back down. Yeah. So for impulse or single sample based signals like impulse.kr, blip.kr, or dust.kr, we're never going to actually activate our sustain because we're not keeping a value above 0 for more than a single sample. Does that make sense? So if our incoming sample or our incoming signal, oh, here's a question for you all. What is? Yeah, that's 0 decibel reference. We're in a linear system right now. We'll get into that later. So right now you're just 0 to 1, 0 to 1. What's going to happen here? If we have a sine os as our input signal.
Then it's going to be going on and on.
Are we going to have a sustained value?
Yeah, as long as it's above 1.
So whenever our sine os is on the top part of the, is above 0, we're seeing it like right here. Our envelope, it gets on and is at the sustain level. As soon as it drops below 0, we have our release. Think of it as if-then statements, logic book. The sustain level is just a level to hold at as long as we're above 0. If above 0, then sustain at this level. And it's just arbitrary. We're applying it to amplitude, but it's just arbitrary. It's just a signal. It's going from 0 to 1 back to 0.
change the level if we're at one.
If the input signal is greater than 1, then we have a sustained level of 1. Well, in this example, right here, signal is sine oscillator. In this one, it's dust, so it's a stochastic impulses. In this one, it's mouse X. In this one, it's an impulse. It's just arbitrary. We're just creating arbitrary signal flow diagrams and if-then statements with them. God, it's fucked up. It makes it really hard on the brain. Don't do that. Yeah. Yeah. Yeah, you're gonna have to chew on it for a little bit, and you might have to come by my office hours. Yeah. Okay. So envelopes create complex versions of this linen. Who did the circle? Maya, you did circle? Yeah, so we can do all kinds of envelope shapes. If we open up envelope help, there's a whole bunch of default envelopes. There's linen, which is the same as linen.kr, includes attack time, sustain time, release time, and level. That's a little bit different. This is where Bearcat's wanting to see a sustained time specified. Oh, test dot plot is how we can test it. So as an example, allows us to see what that would look like. Triangle just creates a, go backwards, triangle. There we go. Triangle creates a triangle. Oh my gosh. So that's not too surprising. Sine creates a sine wave envelope. Percussion. Percussive looking one. Cool. Then we start getting into some whacked out stuff. And then there's sustained envelope creation methods. That allows us to do some really cool stuff as well, like ADSR. And there should be an example here for ADSR. So notice the arguments that we're inputting here are attack time, decay time. So attack time is how long it takes us to go from 0 to whatever our peak level is. Decay time is how long does it take us to go from our peak level to our sustain level. We will stay at our sustain level until our gate is below 0, which I know is frustrating some of us, but we'll think about later. And then decay time is how long does it take us to go from our sustain level back to 0. It was just an ASR. Yes, in some ways. So, let's figure this out. If we over here grab this. Whoa, made something unhappy. We're gonna go on dot. Let's see this. Whoa. Dot ADSR. Attack time 0.01. Decay time 0. We'll just keep the default values. Sustain level of 0.5. And in this case, we want our sustain level lower because we want our peak level to be the highest level. Anything else we want? Curve bias, we will leave it -4. Now we say on is equal to on gen.kr. Create an envelope create and specify an envelope shape. Create a signal from the envelope. Yeah, we're overwriting it, but that's okay. Not a problem because we can be flexible working downwards. Our gate is we're going to use any of these other gates we've been using. So we will use impulse for the moment. Well, yeah, we'll use mouse x.kr. We'll go from -1 to 1. And that's our gate. And for the moment, well, level bias 0, time scale 1, done action 0. We're going to ignore those because I know they don't mean a ton to you yet. And this is still applied to amplitude. So let's see if this works. So if my mouse is above 0 again, we leave the envelope open. The difference here is that when my mouse goes above, when my mouse is greater than 0, we do an attack, decay, sustain. As soon as my mouse goes below 0, we release. That's why we hear the ping. If we had a sustained level of something like 0.1, you hear a significant attack and then a very short, small, minimal sustain level. Sorry, we're going to start over here. Yeah. So this is how you can start to create some kick sounds. And then, of course, something lower. And then also if we did something more like sig plus white noise .ar, we'll do a more different 5. Yeah, you need to filter that white noise a little bit, but you can start to hear it. Sorry, Jared. It's just the gate is looking for some sort of signal that goes below 0 to above 0. Mouse is just convenient for me right now. That's certainly a way to do it. Cole mentioned we could have some sort of Arduino-based controller that was sending values in. We could get data from Twitter. We could have a sign or some sort of other audio signal. We can track amplitude at a microphone. We can get MIDI data. It's all just flexible signals. This is the hard part, is that it's all just like fucking abstract nonsense. It can be anything. Yeah, you can be upset.
So here's the thing, one of these properties, let's say decay time,
Yeah,
does 0.3 mean 0.3 seconds after our point of origin, or does it mean we're multiplying?
means 0.3 seconds after we go below 0 on the gate.
After we go below 0, what determines whether it's below or above 0?
Right now, mousex.kr.
0.3 seconds after we, okay, so the same level is decay time.
The sustained level is amplitude.
Release time is going to release 0.1 seconds after the gate opens.
Oh, no, sorry, I messed up. So attack time is 0.1, so it's a quick attack. Our decay time, our initial decay time is 0.3, so it's a longer decay, down to a sustained level of 0.1.
If I'm working with MIDI data in my DAW, and I get to it, and I change the attack, it basically changes the impact of the attack.
Yeah.
Right? So,
Same thing here.
so I'm hitting harder on my
If I have an attack time of 0.1, it changes it. 0.01, you hear more of a ping. 1, and we can create some really whacked out curves. I mean, this is where we start to get into kind of fun synthesis land, that we can do whatever we want. And far more flexible than most MIDI synths in some ways. It's also far more constraining because you have to understand what each of these things is doing. Or you just button mash and something happens and you go, happy accident, brah. Yeah. Or eardrums or a computer. Or you get frustrated, you throw your laptop out the window and you give up and drop my class. All right, we're unfortunately out of time. As a reminder, I have office hours Mondays from 12 to 1. I also have online office hours, and I've allowed for 30-minute scheduled office hours later in the afternoon on Monday. The constraint this semester is that I do have this new kid, and so I'm trying to open up as much time as possible, but I'm struggling to kind of fit everything into my weeks right now. If you can't find anything with me, feel free to email me and we'll find another time outside of what I've got posted, okay? For next week, same thing, just another sketch. This week, I'd really like to see people use envelopes in some sort of way and think about triggering envelopes somehow. Okay, cool. I'll upload these notes right now. For those of you on Zoom, thank you for joining us. Yeah, fucking study jam.
Thank you.
Welcome. And I'm also going to upload, of course, the Zoom lecture.